don't see you wearing a pair. I want to see these.
Okay, we're now live, so let's get going. So before I kick off with the material I'm going to cover today, I want to talk about the rest of the semester. I have planned out, for the most part, everything we're going to do for the rest of the semester. So here we are, week 10. This is us right here. So what I'm going to talk about today, I have several kind of general things to talk about, and then I'm going to focus on case study 4. Instead of doing a video module this week, I'm going to have a live Zoom Q&A support Thursday at 4 o'clock. If you want to see me do something or you want to ask me a complex question, send it to me and I will do something. I will also answer live questions, and since we'll be on Zoom, you can do screen sharing and you can show me model that you want or whatever. I'm going to give that a try, and for those of you who can't make it, I'm going to record it. That's what we're going to do Thursday. Okay, so the rest of the semester, my initial plan was to have the 5th case study be based on the ISO 95 template. I changed my mind. I'm not going to do that anymore. So the case study 5 is going to be kind of, you can think of it as an extension of case study 4. Okay, so the content in case study 5, we're not going to have any more semio stuff. No more semio concepts. It's going to be based on what we've already covered. There'll be some extensions, but nothing new. And it's going to be, ideally, since you guys like this word so much, substantially more analysis than the previous ones have been, right? Because when you do real-world modeling, you spend a lot more time using a model than building a model. In a classroom, it's the opposite. You spend a lot more time building the model, and then you don't really use it. And the reason for that is generating data for meaningful scenarios is extremely difficult. So I cannot tell you how much time we've spent trying to generate good data to make the scenarios work like we want. So anyway, that's my plan for case study 5 is some modifications, but then more experimentation. And so I decided, as I said, the original plan was to move into ISO 95 template to do that, because the things that we keep adding to our basic case study, we're working our way towards that, right? We're almost to the base ISO 95 template where we are right now, not quite. And so I decided instead of just taking that extra step, I would not do that. However, the ISO 95 template's important, so I'm going to spend time talking about it in class. It's just not going to be involved in the case study 5. Okay, and so you can see the rest. We have a guest lecture here on week 12, which is going to be by Zoom. I'll talk more about what that is as we get closer to it, but just note that. And you also see that I have on the last week before the test that I have a detailed review of material for exam 2. So I'm going to spend the entire class period talking about review. So what I typically do in review is I just sort of give an outline and answer your questions, but I'm going to do something more substantial this time. So I will prepare some material so that we can talk about the base concept, because I know there's some amount of anxiety over a short answer test for exam 2. So I will spend some time doing that. Cumulative, yes, the exam is cumulative. Yes, there's really no cutting off point to say what's important. And also when I did the review, I'm not above putting the same question on where the question's important and there was some misunderstanding. So yes, it's cumulative. Okay, so that's our plan for the rest of the semester. Again, don't forget about the live Q&A. Again, I will answer whatever questions you have, but if you don't ask me questions, I won't have any new material to present. So if I don't have questions or if I don't have anything prepared ahead of time, it'll be an awful short Zoom. And if that turns out to be productive, I'm happy to do that mechanism going forward, because there's a couple other semio concepts I want to use some of this time to do, but I'd rather spend the time answering your questions about case study 4 and 5 than doing new concepts that we're not going to use in this class, no matter how important they are. So I want to make sure that for case studies 4 and 5, you guys have adequate support to do that. Okay? Questions about our plan here? Okay. I got a couple of questions, so I will answer these. I got one from Eliana 4 minutes before class started, I will note. So I was going to talk about, interestingly, the MakeSpan dashboard anyway. So it was a good fortuitous question, but so since you probably haven't had time to look at my response, I will just show it to you, and you can answer in front of the whole class.
Video module 7.
Where? Oh, it's in video module 7. Video module 7, dispatching. Okay, here's your question. I noticed the make span, the simple scorecard is not correct. It's 193. What am I missing in thinking 193 is not 192.94 rounded?
But the thing is in the scorecard is 179.
So the 193 here is you're showing me something different?
No.
Oh, I see what you're saying. This is one, and this is the other one?
And then the other one is
Ah.
179.
Okay, yeah.
I didn't notice because when I run it, I said, oh,
Okay.
I have a number there. But then I said,
I'm looking at this 193 and this 192 and say, well, I don't know what she's asking, but now I got it. Now I understand. And the reason I was going to bring up the dashboard is because I didn't really talk about it in the module on dashboards. Let me get where I'm going here. As to how to do the make span is an interesting dashboard because you have to figure out how are you going to define make span. What is it going to be defined as, and how do I extract the data from either the logs or the tables that you have access to. And so the way that it's computed here is, open this, is it took the date time difference in minutes between the minimum start time and the maximum end time from the resource log. Okay, so if you have the resource usage log, this is basically saying, I'm going to find the minimum start time in the log, and I'm going to find the maximum end time in the log, and I'm going to do a date diff in minutes, and then change it to decimal and round by 60 so I can get decimal hours. Okay, that's what that computation does. So if, in fact, you were defining make span as the earliest resource start time and the latest resource end time, this will give it to you. If you define make span some other way, like the time that your model runs, then this might or might not be it. Okay? If you define make span based on order times, like order release and order completion, then if you have orders that came in early, because we have that release time, so we can have orders whose arrival time is before the start time of the model, right? Then you have to be cognizant of that. So the make span one's a little bit tricky in that you have to decide how you're going to define make span and then figure out how from the data that you can report that make span. Okay, so for the particular one you asked about, I'll have to go back and look because I don't really know how we computed it and why we would see that difference. But I will be happy to do that. Okay? Let's see. Onward we go. My second question here. What happened to my screen? My slideshow here. Had to do with an error that one of you guys was seeing with the dashboards. And so I didn't put this up here because I have a solution, because I do not have a solution for this problem yet. I just wanted to point out, if you look at this in the discussion forum, there's a conversation about how to ask a whole bunch of questions about what you're seeing. And so for situations like this, where this is a clear anomaly, right? This is not like a coding error or something. There's something weird going on. Being a little bit more explicit about what you've tried, what version of Simio you have, and all of that stuff is going to speed up this whole conversation about what could possibly be happening. So when you're asking a question that's really, you know what I mean when I say this kind of question is there's something really weird going on here. Okay? More information in the discussion is going to speed up. And that general concept also propagates to when you ask technical support questions. You have to give them all the information or you have a long conversation about that. And so I asked that. You can see that in the follow-up. And I have never seen this, by the way. I've never seen this behavior, so I'm interested to see what we happen. And if anyone else has seen it, please chime in on the discussion that you have seen that also. And lastly, back to our friend's dynamic selection rule, standard dispatching rule. And this question about if we don't use a repeat group, then we can only define one tiebreaker rule. So to refresh your memory, if you look at a transfer node and you use the dynamic dispatching or the standard dispatching rules, you can either use a repeat group and define as many of them as you like, and they're executed in order, or they're evaluated in order. Or you can use one fixed one and a tie break and single, so you're limited to. So this question has to do with being limited to 2, and if you do, well, what happens? Okay, so if I limit it to 2, and in the second tie break rule, I still have a whole bunch of ties, what happens? And then further, do we have, is this why we would want to a reasonable justification for that repeat group? Okay, that makes sense? So I have 2 things about this. First of all, I'm not exactly sure what happens here. I suspect I know what happens, but I do not know for sure. Okay, what I suspect happens is that it uses the ordering in the queue. That what happens is it takes the ordering in the queue, and when you're executing one of the dynamic selection rules, what it does is it evaluates according to the queue order. So whatever order the queue's in, the evaluation process happens in that exact same order. And how the evaluation process works is Simio internally is going to keep track of the best answer for whatever the dispatching rule you're using. It's going to do that in order. And so what gets created at the end is another queue that has all the tie values for the last rank dynamic selection that you have, and then it just picks the first one off that. Okay? You understand what I'm saying? So basically it's just going to default to whatever the order in the queue. The second thing is that when you ask questions like this, you need to learn the skill of saying, well, I'm just going to create a test model that's going to help me kind of figure this out. Okay? Because you will have this situation all the time where you need to know how is something going to behave. And so you have to have this ability or say, well, let me just figure out how to create a little test model to do this. Okay, and so that's what I did here. It's not exactly the same as the question because I didn't want to go through all of the trouble of creating a transfer node or changing one of the other models. I just want to do something really simple, quick and dirty. So that's what I did. So what I have is a source. I have a server. I have a sink. You can see that I have my server. I have a breakpoint here on my server. And if you look at my default entity, I defined 2 state variables, my random number 1 and my random number 2. And then I went in my simple little model, and for my source, I said, I want to create 5 of these guys, and I only want to create 1 batch. So I'm going to, at time 0, create 5 of these, and so the net effect of that creating 5 is those 5 are all going to be in this queue at the same time, and then I can look at it and say, well, how is this evaluated? Okay? And the last thing that I did, well, the last 2 things that I did is for the default entity, I have a dynamic label, and my dynamic label shows those 2 random states. Okay, and that's why my queue is all funky here, which you will see when I run it. In order to be able to see those, because I didn't want to go through any string formatting. I could have made it look nicer, but I decided I didn't want to do that. And then finally, I just assigned 2 random numbers. So I assigned my random numbers to be random, uniform, 1 to 10. All right, so every time my 5 entities are created, I sample 2 random numbers for each entity. Okay? And then in my, so here's what's different from the question is I did this all in the ranking rule and the dynamic selection for the server rather than for a transfer node. And it's treated just a little bit differently, as I'll show you here in a second, but not substantially differently. Okay, so I have largest value first for my random number 1 for my queue ordering, and smallest value first for the same thing for my dynamic selection rule. Okay, and so if you run this, because I have the breakpoint here, I'm going to run to the breakpoint, and I'm just going to step, because I know what's going to happen is I'm going to end up with 5 entities in my queue. And now you can see why I have that funky queue shape so that I can see all the numbers. Okay, so if you want to see all these numbers, you got a couple of choices. You can either format them nicely or use a point-oriented queue, because if you just use a regular queue, they'll all smush together and you won't see them. Okay, so now you can see the ordering. So here's the largest, next largest, next largest, next largest, next largest. That's the ordering of the queue. And so the dynamic dispatching rule that I'm going to implement says pick the smallest one. So what I expect to happen is this guy to be selected for service, right? So step till that happens, and yeah, that happened. Okay, again, this is the behavior that we expect, right? Because what it's doing is it's ordering the queue as we told it, and then it's selecting using a different rule. So again, we're still in our expectations. So to answer the question, what we now need is I need that dynamic selection rule to have a whole bunch of ties. Right? If the dynamic selection rule has ties, then we're going to see, well, how does it choose which one to do? Okay, so if I go in my thing, what I did was, and there are a whole bunch of ways to do this. This is just one possible way to test this out, is I went in and said, let's make the dynamic selection rule the priority. Right, and if you remember, all of the entities by default have this initial priority of 1. And so if you don't reset those, every one of them is going to have priority 1. Okay, and so now if I do that same execution, if I just run, get to where I have my 5 entities in the queue. Okay, now when it's trying to allocate that resource, it's going to use a dynamic selection rule where they're all ties. So it's going to see all of those. So the question is then, okay, well, which one does it choose? Right? And it chooses this one. Okay? I think. Pretty sure. Hopefully it does. Otherwise, I'll be totally dumbfounded. Yeah. So it chose that one. Okay? So here's some evidence to back up my theory that, okay, it uses the queue ranking rule. Okay. Is it proof? No, this is definitely not proof. This is evidence. Right? And depending on how important it is for me to know precisely what's going on will dictate what I do next. If it's really important that I know this, I'm going to do some more experimentation and try to convince myself doing more things. If it's not that important, then I'd probably leave it here and say, yeah, that's what happens. Yeah, what was the question?
I want to do this.
Yeah, this is not proof. So when you build these, it fits in with our expectation. And then the last resort I would send a semiotech support request, which you guys, since you're on academic licenses, don't really have access to that. But that's what I would do, is I would just try to convince myself, and the more important it was, I would do that. Okay? But I will note, sending a semio support request is not as easy as just sending a simple little email. I would have to send them this and go through a pretty lengthy explanation of what I'm trying to figure out. It's not just as simple as having a conversation like we do sometimes. It would be like, give me the exact problem, give me a use case, and then what you're asking. Okay? But this idea about being able to build models like this is really important. Really important. And you don't always have to start from scratch like I did here. You could start with your model. Take any one of the electronics models you did, delete all of the order records, and create some order records that do this exact same thing. Have priorities misaligned, and just watch what happens. Okay, and one of the reasons that is really beneficial to use the table binding is because that's easy to do. I want to create some of my own order records, do it in Excel, read the table in, and it's really easy to experiment with. Okay. And that's it. That's the only questions I have. So there we go. Anybody have any other questions for me?
I have some questions about case study 3.
Okay.
For case study 3, we never produced the modules, like in the videos. And I wasn't sure where we should put the produce step.
Yeah.
Because they're technically kind of produced after assembly.
Yeah, that's a good question. Thank you for that. I left that out of the video. I did expect you to produce the things, but hopefully Grant won't be mean enough to take points off if you didn't, since I never told you to do that. But the part of the plan was that you would do that. Okay, and so the question is, well, how do you do it? Where do you do it? And that, is an important question, right? So you have to decide, what does it mean for something to be produced? So we have these modules A, B, and C, and when you produce one, you're adding to the inventory. Well, when do you consider something added to the inventory? Is it after you paint it? Is it after it's boxed? Is it after it's shipped? Do you put it in inventory and then pull it out of inventory after it's shipped? Right? All of those things are really easy to do, but you have to make a decision of how you're going to define inventory, which I did not do in that case. I didn't say, here's how I want you to handle it. In my model, I think what I did was produce them in package. So if you look at my model here, I think somewhere down here, produce. Yeah, I added another step, another task, saying, hey, produce these. And so in my plots, you can see the ABC inventories going up. Again, you didn't have to do it that way. You could easily do it on ship. So I could have an add-on process that uses a produce that produces the orders dot quantity. You could do it there. You could, again, define it at the end of finish. Say it's painted, it's not boxed, but it's still technically produced, and put it there. Okay?
Do you have to be a produce step, or could be just counting the products that?
Well, I mean, again, when you say does it have to be, so the way I designed the module, and the case study, I clearly was not clear on this, is that I wanted you to use produce because I have modules A, B, and C defined as materials, finished goods. And so what I wanted you to do was say, okay, we're adding to our inventory of finished goods by producing these. But I said I didn't tell you how to do it. And so the question that I think you're asking is, well, could I just use a counter and not use a material? Sure. You could not use a material element, count it. Those are nuances that would come into, if you were assigned a task, I should have told you what I wanted. If you were designing this model for your use, it's what you want to use it for. It's how you are going to use the information as to how to do it. Okay. You said you had a couple of questions on 3. What else?
I had a second question, but it left. So if
Okay.
I remember it, I'll let you know.
Okay. You can stop anytime and as we go through today, and I will be happy because I have my version of module. This is actually a mix of case study 3 and case study 4 in what you see here, but I have it there. So let's see what we're going to do now. As I've already said, case study 5, follow on, which leads me to this notion of dashboards and your conversation about extra credit. I'm pretty sure I've given extra credit before, but honestly, I don't remember the last time. I'm not a fan of extra credit in the general case, but I decided to do it this time. So you have the assignment, and yes, my terms of substantially more and all that are intentionally vague because there's no way to quantify what it has to be. I mean, you have to understand what the dashboard's doing, what the intent is, and it has to be well defined. So I can't tell you exactly what that means, but I know it when I see it. Such is life with extra credit. Okay, and as I said in the assignment, this is a substantial amount of extra credit. Obviously, if you already have 100% of the points, it's of no value to you to get 10 more points. If you don't have 100% of the credit, this is a very large piece of extra credit that I'm giving you. And so I expect, if you look at it just in terms of the work content, okay, 10% of your grade is essentially one of the case studies. Not the first one, which is 5%, and the last one, which is 15%. But the other 3 are 10% of your grade. So you can think of this one dashboard. That's my expectation if you want to get all 10 points, is that it's substantial. Okay? But you also have to do dashboard for case study 4. And you are going to use the dashboards in case study 4 and in case study 5, so you're already going to be doing it. So the better dashboard you make, it's going to help you with case study 4 and case study 5. And, can do extra credit too by making video or something like that. Of course, you also have really simple dashboards that will help you. Like my simple scorecard is what you use for case study, and it's really useful. Not particularly interesting from a dashboard perspective, but quite useful from an experimentation perspective.
I remembered my question.
Okay.
So on the finish, you said that the racks have room for 10 modules.
Yes.
And the orders don't go above 10, but some of them are like 3 or 4 or whatever. Is there a way to model it where you could put modules on the racks that are the same colors to completely fill that capacity instead of just processing one order at a time? Yeah,
so you could do that. It would be some work based on what we're doing here. You'd have to do some restructuring, but you could have a resource that essentially you would think of the rack as a resource that needed to be fully used before it progressed. So yeah, you could do that.
Why don't we do that?
Complicatedness, yeah. It's a good idea. I might do it next time, though. Yeah, complicatedness. I was trying to make the model not all that complicated. Okay, other questions for that? Okay, so let's. One other thing I will say. So I'm gonna talk about case study 4 today. I'm not going to read it to you, but we're going to go over some of the general concepts. I'm going to show you a little bit of the technical details. But I will say one thing that really thought about doing, but I decided to push it off to case study 5 is a model verification report. In case study 5, you will have to explain how you verified your model. Okay, and you should have been doing this all along, not reporting it to me, but keeping track of how you do it, and I'm going to make you report it. Okay, so pretend that you are in the working world and you're going to give this to your boss, and the whole idea of the model verification and report is to convince your boss that you did it correctly. That's what I want. So that's coming in case study 5. Case study 5 is going to be a variant of this. So anything you do in this one is going to go forward to that. So you should definitely be thinking about that. And it has to be more than, hey, I just watched the model run. Okay, and when you get further into today's class, I'm going to give you a specific example where that becomes important based on my experimentation. I will come back to that. Okay, so case study 4. So what we're doing in case study 4, a couple of things. First of all, we're adding 3 more modules. We had module A, B, and C, and now we have modules X, Y, and Z. But these modules X, Y, and Z are not just random modules. They're analogs to modules A, B, and C that are just not painted. Right? So you can think about an unfinished furniture store, right? You can go buy a chair that's natural wood. You can go buy a chair that's painted. They're both a chair, and so on. Okay, and so you're taking this idea of saying that we are having unfinished versions. Okay, and that has a couple of implications. One implication is parts of the routing are the exact same. Okay, so when I take a module X, it's exactly the same as a module A at kitting, and it's almost exactly as a module A at assembly. Okay? Same thing with model Y and module Y and module B and module Z and module C. Okay, so they're in kitting and assembly. In kitting, they're the exact same. In packaging, in assembly, they're almost the exact same, and they don't go through finish or packaging. Yeah.
So in that case, we don't need boxes for.
Yeah, you don't need boxes because they. Oh, what do I say here? Somewhere. They're bulk packed in shipping totes. And because they're bulk packed in shipping totes and those shipping totes are reusable, we're not considering those as consumable material. And so that's code for you can just totally ignore those shipping totes. Okay? So that's kind of the basic part of the problem. Okay? Another minor thing here. Oh, there is that second packaging. So when I say they're almost identical in assembly, they're just a little bit different in that you have that bulk pack step. So the bulk pack step for these new modules happens at assembly, not at packaging. Okay, so the assemble process, the actual assembly process is identical, but then there's that one more step of bulk packing them. Okay? Okay, so because now we have 2 different types of modules, the unfinished ones and the finished ones, we also introduce a sequence-dependent changeover at assembly. But the sequence-dependent changeover is between these 2 classes of modules. Right? So we had modules A, B, and C, and they had a sequence-dependent changeover in finish. But now we have this kind of different concept where anything in X, Y, or Z that changes to anything in A, B, or C, I have a sequence-dependent changeover. So it's not that it's from A to X, or B to X, or C to Y, or something like that. It's anything from the group ABC to anything in the group X, Y, Z, you have this sequence-dependent changeover.
So this is an additional time?
This is an additional time, exactly like in finish. So after the setup in assembly, like we have before, if it's one of these XYZ module, or if you're going from an ABC to an XYZ or vice versa, you have this setup. Yeah.
Can this be done with the 2x2 changeover matrix?
Yeah. With one little caveat, is you have to introduce this notion of classes of modules. Right? Because we had module in the changeover matrix that we had before, we had the module. Here we have classes of modules. I have ABC modules and I have XYZ modules, and so I need to form a 2x2 matrix that uses that classification.
Is there any problem with not doing a 2x2?
6x2.
Like doing a 6x6?
Yeah.
I cannot think of any problem off the top of my head. But we do have this other part of this classification also. So another part of the classification is somewhere down here. I tell you I want you to be able to prioritize the XYZ orders or prioritize the ABC orders. So when you're dispatching, I want you to say, hey, the XYZ orders are more important. Right? So you're already going to need a way to differentiate between what an XYZ order is and what an ABC order is, over and above just this one. So I don't see any reason why you couldn't do a 6x6, but I also don't know why you would, because you're already going to have to differentiate between these module classes anyway. Okay? So let's see, we have that changeover matrix. Oh, and you also need the changeover operator here, okay? But we're going to assume we have two of them. So you had a changeover operator for finish. We're going to assume you use the same one, but you have a second one, okay? And for this one, I said use a pooled resource strategy. So what a pooled resource strategy means is that I have two operators, and either one of them can do either task. So either operator can do a changeover on assembly, and either operator can do a changeover on finish. Okay, and so we're pooling those operators. And the easiest way to implement a pooled resource strategy in Simio is to just use one resource instance with capacity 2. Okay? Makes sense? Everyone understand what a pooled resource? So when you talk about resource strategies like this, you basically have pooled and dedicated, and then you have some hybrids in between. If you have a pooled resource strategy, anyone can do anything. If you have a dedicated resource strategy, I would take my two operators and assign one of them to finish and one of them to assembly. Okay, pooled versus dedicated. Why do I bring that up? Because we might revisit this in case study 5. This very thing about using a pooled versus unpooled or dedicated. Yeah?
So why is it the easiest way to do a pooled resource by having one unit with 2 capacity?
Why is it the easiest?
Yeah, so is it in terms of like balancing out utilization and stuff like that?
Well, I guess what I mean here is it's just the easiest because I just plop down a resource and give it capacity 2. But, I could also implement a pooled resource strategy by creating 2 separate worker objects or 2 separate resource objects and using a list, select from the list, and then use one of our, cyclic policies or something, and it would still achieve the same thing, but it would just be a little bit more work. If you do that, select that list, though, strategy, so suppose I use 2 workers rather than 2 resources, then I can see each one individually. So if I have 2 workers, Joe and Ann, I can see them individually. Whereas if I do this strategy where I have one resource with capacity 2, I just see one resource and it sometimes has 1 and sometimes has 2. Okay? Okay, so I give you the changeover times, and let's give you some stuff that they're basically the same. And the next thing I'm going to do is I'm going to give you a material arrival table. So rather than having you go through the exercise that you already did, where you said, where do things run out, do that. We're going to do the same basic thing where you're going to replenish the inventory, but we're going to give you the replenishment strategy. So we give you the table, and you just implement that table. So now our scenario, where previously we had order file and materials file, now we have 3 files, an order file, a material arrival file. Okay, and then I give you an example of what this material arrival file looks like. Okay, so let's go further a little. I'm going to come back and talk about some of this, by the way. Right now, I just want to define the problem. So I want you to make a couple specific changes to the model also. This first one says when routing from transfer nodes to the corresponding server-based objects, we use node lists. Right? So you guys remember that in case study 3? I said, select the input node for finish 1 and select the input node for finish 2 and the finish node, and then right-click and create a list and use select from list. Right? This time I want to use a different strategy. I want to use a routing destination table. Okay, I'm going to demonstrate that here in just a second, so when we come back to that one. The second thing is the aforementioned dashboards. Use whatever ones you want from the what I did for the video module, but you need to come up with 2 more. Okay, and the 2 more, I want to be informative. I don't want them just to be a rehashing of what I've already given you. Okay? And so this is sort of goes into the whole extra credit. Also, the better dashboards you make, the more information you have, and the easier your job's going to be to do the analysis part of this assignment and the analysis part of 5, but then you have the whole extra credit thing. And so it's worth your time to do this. Okay, and as I mentioned in the video, I'm pretty new to dashboards. There's substantial opportunity that we have not even looked at in terms of different types of graphics and different types of information. And so that's what I'm looking for, is for you to go beyond what we did in class. And, you know, obviously, selfishly, I want you to teach me how to use them. Okay, so dashboards and routing nodes. I will again come back to the routing transfer nodes here in just a second. I tell you specifically what I want you to track, what Obby Electronics. The first three are the same thing that we've done before. Make a note for number 3. I specifically defined fill rate this time, where there was some ambiguity in how you defined fill rate last time. I tell you what exactly I want that exact calculation to be. So we've seen make spans subject to the stuff we talked about today. I will come back and talk about what specifically I want for make span probably next week or in a Canvas announcement. And then there's this fourth one that I want you to come up with a metric for. And so this notion of material blockage. So we're gonna give you the replenishment file. And so there are gonna be times where modules are blocked by materials. So, you know, I'm making A's that are red and I have no red paint, right? But all of the scenarios, knock on wood, are configured so that everything can eventually be produced. So there will be no material shortages that will cause an infinite block, right? But you will have blockage, right? So the two extreme examples I give here, one says just have a whole bunch of everything available at time 0, you never have any blocking. Versus you have nothing available at time 0, and at the very end, you have all of the materials developed. So, you know, maybe 3 weeks from today, everything arrives and then you produce everything. So then everything will be late, okay? And so that material blockage, when a material comes to a step, when an order comes to a step and the material's not available, it's blocked, okay? And we looked last time at how to see that in the constraint log. All right, you guys all with me on the concept here? So you know what happens. You know how to find when it happens by looking in the constraint log and the plots and all of that stuff. So the task here is to create a metric that I can use. Okay, to create a metric to say, okay, when I run scenario 1 versus scenario 2, the material blockage is worse here than here. Well, how? By what metric? So that task for 4 is to come up with a metric. Okay, and then to implement that metric in a dashboard or in some way that you can go back and evaluate it. Okay? Let's see here. So, using the developed model and the 2 provided scenarios, note my little red footnote thing here, come back to that, do the following, do a baseline run, FIFO, no dispatching, do a run using least setup, earliest due date dispatching, all the 4 performance metrics, do a run where XYZ orders are prioritized over ABC orders, report everything, and then figure out how to minimize or quote, find the best make span by having whatever configuration of dispatching rules that you would like. Okay, and note for all of you optimization people out there, I don't mean that you have to give me a provable optimal solution. I just want you to look around and find a good solution. Okay, so there's no need to do any actual optimization here, just a little bit of exploration. Okay, I also give you the start time for all the runs, which I didn't do last time, and then you deliver to me. I give you all the deliverables, I don't need to go over that. Zip all the files together, submit them on Canvas. My note about don't share XML files for your dashboards here. You have to create 2 dashboards. I want these 2 dashboards to be your dashboards, not you and your 3 favorite friends' dashboards. At the end of case study 4, you guys are free to share all of the dashboards you have come up with. Put them on the Canvas site, share them, improve upon them, whatever you would like to do, but not for case study 4. Okay? And then finally, the asterisk here. So we're still working on the final 2 scenarios. We don't have the final scenario data files, but we do have sample data. So in the assignment, you will now see order sample, material order sample, material sample. And so you can do the model development, you can develop the dashboards, you can develop everything that you need to do using that sample data, but the actual analysis, we don't have the data yet. Okay, and I will just point out that, as I said, generating this data turned out to be a lot harder than I anticipated, but also this is what you see in projects all the time, is that you have sample data, but you don't have real data. You get the real data kind of a little bit later on in the process. Okay, anybody have any questions for me on what the case study is and what the expectations are? Okay, so let's talk about the model here. And so let me again point out in the schedule. So you saw holes in my schedule because I want to assist in making this happen and do it, but you've got to tell me what you find confusing and what you're having trouble with. If no one asks questions or says I'm stuck here or whatever, then I'll find some other material to fill that time. If it's beneficial for us to spend time talking about specifics of case study 4 and 5, I'm happy to spend class time doing that too, but that's all got to be directed by you as to what you're finding difficult and what you'd just like to see me go further in exploration of. Okay, so that is going to come to you, or I'll just find some new material to talk about. Okay? All right, so I want to spend the rest of today talking about a couple of conceptual design things here, and then I'm going to show the specifics that I mentioned before about routing destination table and all that. Okay, so remember this conceptual design step is you have the assignment, and then you're just kind of thinking through in your head, and usually, at least when I do it on paper too. I'm not going to do it on paper here because we're going to talk about it, but you can see that I did do it on paper here, right? And then talk about the basic concepts, okay? And the absolute worst thing you can do is read the assignment, open case study 3, make a copy of case study 3, and just start typing away. Okay, that is a bad, bad idea, okay? It's tempting. It is very tempting. Bad idea, okay? All right, so let's think about what we're going to do. Well, obviously, we need to create some more modules. X, Y, and Z, okay? We know that. And because I've told you the routing matches, right? The routing is really going to match for kitting and assembly, and then they're just going to jump to shipping. So in your mind, hopefully you're thinking, well, we have that routing, we have the routing table. Just need to create new routing entries for X, Y, and Z where they match for kitting and assembly, and then they just jump to shipping, right? So again, you're not doing this in Simio, you're doing this in your head. You're thinking, yeah, okay, that'll make sense. I can do that. Then we have a slight modification in the assemble. We have this changeover. We have a sequence-dependent changeover, and we also have packaging, right? So in our head, we're like going, okay, I have to modify assemble to add these tasks. Both of these will be conditional tasks because modules A, B, and C also go to assemble, and they don't have they have the sequence-dependent changeover, but they don't have the packaging. So the packaging needs to be conditional. And so what that tells me is that that notion of conditional, I have to have some way to differentiate between ABC and XYZ, right? And I want something more substantial, more easier to implement than just having this long if statement. If X, if Y, if Z, then this, if A, then B, then B, then C, then this. I could do that, but that would be tedious and error prone. Okay, so I need a better way to do it. Okay, and at this point, when you're doing the conceptual planning, you are not diverging into figuring out how can I do that. You're just tracking what you need to do. Because once you go down the road of saying, well, how do I do that? How do I differentiate between these? Then you kind of get lost in the conceptual phase, and now you're in the detailed phase, right? So it's just kind of, let's just lay out what has to be done, and then go back and fill in the details, okay? So I'm going to talk a little bit more about that here in just a second. And as we said, we also need the changeover table. We have the material arrival table. Okay, the material arrival table, you guys all implemented something very similar in case study 3, right? And so just kind of think about it. You have the sample of the table here. Is your method going to work, or do you need to do something conceptually different? I don't know how you did in case study 3. I suspect that everyone used the table approach, like I said, and then it's just going to be a matter of changing the structure, but you might have done something differently. And then we have this pooled resource strategy, which I've already told you how to do that. But in general, you would think about that if the assignment said pooled resource, how would I do that? And then finally, we have the dispatching rules, and then this one that you have to come up with, which is material blockage, a metric for material blockage. Okay? Does it make sense? So we're going to think about that, and those are basically the changes that you're going to make to the model to make that happen. Okay, and so when we finish that part, conceptual design, then we're going to go back in and start looking at details. Okay, so if you think about this notion of differentiating between ABC and XYZ, right? So I have modules A, B, and C that are in one class, and modules X, Y, Z that are in another class that I need to be able to differentiate between. How do I do that? What are my options for being able to do that? How can I do that? Well, we already saw part of that. We already saw something similar, right, when we did paint. Okay, so when we did painting here, if you look at our orders table, how do we deal with the notion that we had to have the changeover part of the paint and then the element part of the paint, right? So if you look at that top row, we have two things that tell me that's red. I added another column. Okay, so I could easily do that. I could add another column to the orders table, or I could add another column to the materials table, okay, that says, here's what this is. If it's a module X, then it's this class. If it's module X, Y, Z, it's one class, right? You guys with me? You could do that? And it would work. It would work fine. The downside of doing that is you're going to get scenario files that don't have those extra columns. Okay, so the files that we're going to give you don't have those extra columns, so you have to deal with that and say, okay, how do I update these? Okay, doable, infinitely doable. You just have to kind of weigh that off. How else could I do it? How else could I do it? Yeah. You can use an equation. As I said before, that you have that long equation of if it's this or this or this, you could do that. And that would work too. As I said, it's a little tedious and it's a little bit error prone, but it would definitely work and you could do it. How else could I do it? How else could I do it?
We define a string that contains the names of all the modules that belong in a class, and then search that if the name of the module is a substring of that bigger string.
Yeah, so you could use a string search like that and do that. Yeah, so there are a whole bunch of ways to do it. I'm not going to tell you how you should do it, but there are a whole bunch of ways to do it. And the point is that when you do the conceptual design, you want to try to elaborate on all of those before you just start trying to do one. Okay? Another way that you could do it, that you could think about doing it, in the initial model that I did, this is how I did it, is you could just define some entity states. And when an order arrives, you have the logic just like you would have in your complex expression, but you only have it in one place. So when an order arrives, I make the decision of what it is, and I use an entity state. That's another way to do it. Okay, so the idea here is, again, there's a whole bunch of ways to do it. You just have to think through which ones will be are going to be the best for you. Let's see, what else was I going to talk about? Oh, I was going to talk about one of the things for verification that happened to me when I was doing the initial version of Case Study 4 for testing. Okay, so here's what happened when I did this. So in Case Study 4, remember that we have this assemble, right? And the assemble, one of the things we introduced was sequence-dependent changeovers. And we've seen sequence-dependent changeovers here. Okay, so we've seen these before. I implemented it here. And so when I implemented in assemble, I neglected to do one little thing. Okay, I neglected to do one little thing. And the thing that I neglected to do with the sequence-dependent changeovers is, well, I can show it here. I don't have that model because I don't want to show my solution here. We have this thing called auto-cancel trigger that we've seen in the past, right? And when you think about a task sequence, what the auto-cancel trigger does is basically says, what happens if task prior to me is canceled, right? We talked about this in class and gave examples of it. Okay, well, it comes into play here because if you don't set that correctly, and what happened to me is in assemble, I never did the finish steps because when I was looking at the packaging, right? So when you look at assemble, right? So you guys again conceptually have an idea of what's going to happen here. Hopefully, is that when I look at the task sequence, I need to make two specific modifications to this task sequence. I need to add in the sequence-dependent setup, just like we did in finish, but I also need to add in that packaging step. The packaging step is conditional on the module type. Okay, I put the packaging step right after process. Okay? Are you with me? So what I did in my model, my initial model, is I put the packaging step, think of it as number 25 here. But it's conditional on module type. that it be an XYZ module because you don't do that packaging step for the ABC. What I forgot to do was in the finish, then right here, go back and set this to be none so that when I skipped over the packaging for ABC, it would then come back and do the finish. Okay, so I forgot that. No error, nothing. Run the model, nothing. Looks perfectly fine. All the dashboards work, all the Gantt charts work, everything works. But the problem is that it's skipping that step on every one of the ABC modules. Okay, it's skipping that step. Right, you guys with me? So I forgot to set that. So for every ABC module, it didn't do that setup. Okay? And the only way I found it was when I was looking, trying to come up with, some interesting scenarios. I was looking at the resource plan, trying to find interesting stuff, and I just happened to notice I don't see many of those red setup, red finish ones, right? Because the tasks here show, if you look at the task, and again, I don't have it on this one, so it's hard to see, but if you zoom this out, right, you've got, there are my three tasks. You've got setup, you've got process, you've got finish right here, so it's a purple one. There were no purple ones for only the ABC modules. This is the only way I found it. It just happened to see that and say, wait, this is a problem. And then, of course, when I saw it didn't happen, I just go back and fix it. So it's nothing complicated, but you have to find it. And that's this whole notion of verification, is that you have to show that the model is correct. Now, for you guys, you have all your classmates that say, hey, for scenario 1, what was the make span that you got? Or what was scenario, which is perfectly fine, by the way. You guys can discuss all those things. You can't build models together. It's perfectly fine to say, hey, what did you get for this thing? In the real world, you don't have that. You're building the model and you have nothing to compare it to. The only thing you have to compare it to is your verification method to make sure that you got it. Okay, and this example is one where this would be very, very, very easy to miss this if you just didn't have either a formal process of verification, which I didn't follow because I was just developing the scenario for you guys, or you just happen upon it. Right? And so that's a big problem when you're developing complex models, is you have to have a way so that you can be confident that the model is correct. Okay? That was my example of what I'm saying. And so a verification plan would include being able to say, okay, I have task sequences here, I have task sequences here, how am I sure they're being implemented properly? And so in the end result of the task sequences for a symbol, you're going to have the ABC modules follow one set and the XYZ modules follow another set, and you're going to want to say, here's how I know that that was implemented correctly. Okay? Okay. So let's go back to this task that I asked you to do. What did I say? Use routing destination. Okay, and so what I'm going to do is basically show you how to do it and talk about why we're doing it. Okay? It's really straightforward. Ordinarily, I would do this in the video module, but since I'm not doing a video module, I thought I'd just do it right here. Okay, so if you think about what we did, right? Our strategy when we built this model was we were going to use these transfer nodes to do the routing, right? So when I go to Work Center, kit or symbol, finish or package, the entry point into the Work Center is the transfer node, right? And the transfer node would use the select from list. Right, so a symbol, select from list, and as we built this, we just right-clicked and did the list and all that. And so we have a kit list, a symbol list, finish list, package list, and we use select from list. Right, you guys remember that? So if I look at the model and I say to you, what's the difference between all of these entry point transfer nodes? So what's the difference between kit and a symbol? What's the difference between a symbol and finish, and what's the difference between finish and package? And what's the difference between those? It's the specific list I use, right? All three of them use the material constraint logic element, right? Right. So if I just look at the properties, so here's the properties for kit, select from list, kit list, preferred order, selection goal, all of that stuff's there. Okay, and then I also have this routing out logic, which is the constraint logic. And then I jump over here, right? And it's the same thing, except for this one little thing. the assemble list. Kit list, assemble list, finish list, package list. So if it weren't for that, I could use a generic object, right? I would have the exact same object for kit, for assemble, for finish, and for package. Right? If I could just get rid of that one little thing. Okay, and that's the objective of saying, let's look at a different way to do that. Let's look at a different way to implement that list. Okay? So this is not the only way to solve this problem, too, by the way. I could put it in the list table, still have the list, and put it in the materials table, in the resources table. But the easiest way to do it, especially for large-scale models, is to move the data to the table. Okay? So here's what we would have to do. You will have to do. I've already done. I'm going to just create a table. And my table, I'll go over here and create a table. Add table. Let's call this routing destination. Okay, and so the routing destinations with an S, are defined relative to the resources, right? So what's kit, package, finish, assemble, those are all resources, right? So I'm going to have a foreign key. And my foreign key is going to be my resource name. And my foreign key table will be resource rname. Okay, so that I can tie it back to them. And then what I need to specify is the nodes that we formerly had in the list. Okay, so what we're really doing is we're using a table as a list. Okay, so I need to say create a node. And we're going to call this nodes. Okay, and then I just need to create the same thing that I had in the list, but using the related tables. So I go look at my kit, for example. Kit right here. What's the node? Input at kit 1. And I look at assemble. And what's its 2 nodes? I have input at assemble 1. And then I look at assemble. Input at assemble 2. Hopefully you can see where we're going. We would then do finish and have finish 1, finish 2, finish 3. And I would go to package and I would just have package. Right, so we're essentially just saying, okay, I'm going to do the same structure as I had in the list, except I'm going to do it here. But because we have the related tables, now when I go to kit here, once I'm at kit, if I say, hey, show me the routing destination table, it only shows me the related rows. Right? And now if I say go to assemble, it only shows me its related rows. So now we can use the routing destination table as our list because of this table relationship. Right? So I can go back to my model and say right here, instead of having my node list name, I'm going to have routing destination nodes. Okay? And because the tables are related, it's only going to see that one routing destination. That'll look at 1. And when it gets to assemble, as soon as I make that update to assemble, it's going to see its 2. And when I implement finish, it's going to see its 3. Okay? That makes sense? Okay, so quick comment here. Note that this does not show up in the pull down. You have to know this and you have to type it. And it's another one of those scenarios where just because it's not in the pull down list doesn't mean that the entry is not valid. Okay? Well, now I can say, hey, let's go to kit. And let's right-click on it, and let's create a new object and call it AE transfer node. So now I'm creating a custom object for my transfer node. And because I created the custom object based on the one that we had there, one that had specific property values, of course, now the default property values are select from list from the table and also apply that constraint logic element. Okay, and so now I can go back into my data and say, okay, well, kit we just did. Kit we made into 1. Do the same thing with finish. Same thing with assemble. Same thing with package. And now I don't need my list anymore. Right? I don't need my list anymore because it's all handled in the table data. Of course, I haven't finished yet. You would have to do that. But the model will run exactly like it ran before. Also note what this does is it makes it really simple for me to do things like, say, suppose that I want to add a third assemble station. Okay, so I have my model structure. What do I have to do to add a third assemble station? Just conceptually, I want to add a third one. What do I have to do? What do I have to do? There are basically two steps. Add a resource called assemble 3, and add an entry in that routing destination table that says go from assemble. I already have 2, assemble 1 and 2. Just add a third one there, and poof, it works. Okay, so you don't have to manipulate much of the model at all. And the reason you don't have to do that is because we have these custom objects that implement the behavior. We have all of our data, or as much of our data as possible, in the table. Okay, so when you're doing large-scale models, that makes things better. And when you think about this notion of verification, once I have my template, my base template verified, models that I build from the base template are much easier to verify because I've already got the baseline done. Okay? And I'm pretty sure that is all I was planning to talk about today, unless... Oh, one other thing that I will leave for you to think about. If you remember from case study 3, we have these AE servers, right? And when we did finish here, right, we had that sequence-dependent changeover. So we created another object called AE finish. You're going to have the same scenario here when you do assemble, right? Because we're introducing a sequence-dependent changeover there, a different one. And we're also introducing this conditional step of packaging. So you have to make this decision. Should I make another custom object like AE assemble? Or should I just leave it an AE server and have these two instances just have different property values, right? Because that's really the only thing that's going to be different, right? If I leave them as AE servers, then I simply have to make sure that I do the same changes in both of them, but it would work. Versus create a custom object and use the custom object. That's a design decision that you have to make. Okay. Questions for me? Okay, so let me just give you a little bit of advice for this one and case study 5, sort of merging these two together. The changes you have to do to this model are really pretty straightforward. The analysis task is more substantial. You want to get on the model early. You want to make the model changes early. Okay? In particular, when you get to the blocked, material blocking metric, you're going to have to do experimentation with that. You're not just going to be able to, unlikely that you'll be able to just make it up off the top of your head. Okay, so you need to have the model in its base form and verified so that you're pretty sure that it's correct before you do all that experimentation. The absolute worst thing you want to happen, do the model, do all the experimentation report, and then find that you have a mistake in the model. And you have to go back and do all the experimentation again. So spend some time on the model. The model changes are pretty straightforward. Do the verification. Start this process of verification so you can be confident that your model's right before you get to the experiment stage. Okay? Any questions for me? Okay, so I will leave with one more thing, one more comment. Let me just reiterate here how I have this laid out. Back to my schedule. I have a Zoom session planned on Thursday. If no one asks me anything, it will be short. I will spend as much time as you want to spend. I also have a couple of empty slots there to do more stuff. If you ask me questions or if we want to talk about stuff to do with case study 4 or 5, I'm more than happy to do it. But again, it has to be directed by you. There's plenty of other stuff that I can go over. Yes, sir.
The way you have implemented the material constraints for case study 3, entities get blocked even if the material we're missing is very far away at the end of the line, but we can block at the beginning of the line. Since now we're gonna have orders that we know we're gonna be able to replenish material, so we will have material replenishment. do we need to change those constraint logic so
the constraint logic element, the constraint logic elements shouldn't block forward. So in other words, if I don't have box A, I should not block that at kit. That should get blocked right here. So you're not blocking forward. I mean, at least unless you implemented that in your model. The way I did it in case study 3 in the video module is it only blocks at the immediate thing because of the way the bill of materials is linked. Because of the way the bill of materials is linked.
You're out of boxes, for example, and I order a wrapping kit. It is in the box A. I'm not sure.
Box A, because of the way this happens, when you look at the constraint is based on the bill of materials. Okay? And the bill of materials is based on the routing. So when I look at kit, I need component A, component B, component C. And so even though I need boxes later on, if the tables are constructed right, it shouldn't block. It shouldn't block forward. That might be a strategy you want, is to block forward, but the base model should not implement that. Okay? So you see what I'm saying? Did I answer the question about the block? And so as I'm saying, that the scenarios that we're giving you, you will always have enough material eventually. But there will be blocking, there will be stuff that's blocked. You what now? That's an interesting concept I hadn't given any thought. You have free reign on that in defining your metric of what blocking is. If you choose to do that, which might be awesome strategy, by the way, just explain it in your blocking metric that you are using that. Okay, and again, I said I was done, but I want to show you one more thing that I spent an enormous amount of time trying to debug that I will save you a lot of time on. So, if you remember, when we have our task sequences and we want those task sequences to use the bill of materials, you remember that? We had to do the bill of materials table right here. Okay? That little thing right there is going to prevent you from using the produce step on any one of the task sequences that has that same strategy. So if you choose to produce in a task sequence and it has that material reference table, it's not going to work. Because that task material reference table doesn't include what you're producing. It only includes what you consume. So it doesn't see it. So
that means we can't use the bill of materials table.
That means you have two options that I know of. One option, the one that I followed in my sample model, is I just put all the produce in the ship. So I said when I want to produce module A, B, C, X, Y, Z, I just do it at the ship node. So I just had an add-on process and use a produce step. You could also add to the bill of materials what you produce. So what our bill of materials is a consumption bill of materials, but you can also add produce steps there, which would probably be a more elegant solution that would solve more problems for more comprehensive models. Probably unnecessary for this assignment, unless you just are interested in how to do it. Okay? And that is another case where it was extraordinarily frustrating for me because I couldn't figure out what was going on. I had no idea what was going on. I kept producing. I had the produce step. I had the produce step. I had the produce step. And you know what? In my status plot right here, nothing was happening. And after 45 minutes of debugging, I figured out that this was the problem. Okay? Last questions for me? Yeah.
For the Zoom session on Thursday, I have a class on that time. Are you going to post the recording?
I'm going to post the recording. Yeah, I will post the recording.
Is there any way I can ask questions before the class?
Yeah. Email me questions. Email me anything you want me to cover, and I'm happy to do that. You know, if there was a more convenient time, I would do it. I don't know how to pick a time that everyone's not available. I picked that time because I assumed this slot was assumed, but obviously that's not right. Send me a question, and if that doesn't work, we can set up a one-on-one Zoom, and I will do that. And typically, when we get to case study 4 and 5, if you want to do a one-on-one Zoom, I mean, I'm happy to do that also. Okay? All right. See you guys later.